And we're back with Advent of Code 2024, a series of programming challenges that are published every December. There are 50 of them, 2 per day, leading up to Christmas. And in the previous videos, we've completed the 8 challenges for the first 4 days. So now we're gonna move on to day 5. And I am tackling these programming challenges in Funciton, an esoteric programming language that I invented. Day 5, print queue. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation X pipe Y means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. The ELF has for you both the page ordering rules and the pages to produce in each update, your puzzle input. But you can't figure out whether each update has the pages in the right order. For example, let's scroll down a bit. Okay, so these are the rules as to the ordering of the pages, and these are the pages that we need in each batch, I assume. The first section specifies the page ordering rules, 1 per line. The first rule, 4753, means that if an update includes both of those numbers, then the page number 47 must be printed at some point before 53. Okay. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update means that the update consists of those pages. To get the printers going as soon as possible, start by identifying which updates are already in the right order. Oh, so we don't need to order them. I thought we would have to order them. In the above example, the first update is in the right order. Okay, so we're just checking whether the page ordering rules apply or not. So it's just a boolean, and then we count how many of the batches are in the correct order. Because the first update does not include some page numbers, the ordering rules involving those missing page numbers are ignored. The fourth update is not in the correct order. It would print 75 before 97, which violates that rule. The fifth update is also not in the correct order because it breaks the... okay. For some reason, the elves also need to know the middle page number of each update being printed. Because you're currently only printing the correctly ordered updates, you will need to find the middle page number of each correctly ordered update. Ah, I see. In the above example, the correctly ordered updates are these. Okay. So I assume that means that each batch has an odd number of pages. Of course, you'll need to be careful. The actual list of page ordering rules is bigger and more complicated than the above example. Determine which updates are already in the correct order. What do you get if you add up the middle page numbers from those correctly ordered updates? Okay, now I'm quickly going to take a look at the puzzle input. Okay, they weren't joking. The actual list of page ordering rules is indeed quite extensive. Remember in the regular expression video where I said that the regular expression engine is general enough that it can deal with sequences of any elements, not just characters of text? I'm tempted to suggest that this may be the first reasonable use case where we could use that, because we have sequences of numbers and we're looking for specific patterns in them. So for example, the first rule here, 4753, is the same as saying that you can't have a 53 any earlier than a 47. So we could make a regular expression that says look for a 53 and then any number of elements and then a 47. And if that matches, then reject that batch. Now, why am I inverting this? Well, it's simple, because if you have this one here, 9713, and then you have an input that doesn't contain a 13 or a 97, then we want the fact that the regular expression doesn't match to be okay. So we need to turn these into regular expressions that express the conditions that are forbidden, and then filter those out. And then we might be able to optimize that regular expression by bunching together the ones where the second number is the same. So for example, here you have 9713 and here you have 2913. Now let me transfer this to Notepad to explain what I mean. So we have a bunch of ordering rules like this one, which is effectively the same as saying that you can't have a 53 followed by any number of elements followed by a 47. Now make no mistake, this is not a regular expression that looks for the characters 5 and then 3, but rather the number 53 itself. Okay, but then we have another element here that looks for 6153. So instead of turning that into a separate regular expression that looks for the 53 all over again and then a 61, we can instead combine that up here by including the 61 in an alternation. So if I were to turn all of these ordering rules into a regular expression, then I'll get something like this. And now I can sort this numerically, and then you'll see that there are quite a lot of them where the 13 appears at the start. So we could totally just bunch these up together into a single alternation. And then we could turn the entire thing into a single regular expression by combining all of these with alternations. And I'm not completely sure if that would help performance, but it would certainly mean that we're going through the string only once and not multiple times for each regular expression. So that means the bulk of this challenge is really the code to construct that regular expression. So I think I'm going to start with the easy part and write the main program first. So looking at this input, the very first thing that we're going to need to do is to split at this double new line that separates the ordering rules from the main input. So let's start by reading standard input, and I'm going to use the string split function to split it into two parts, using the double new line as a separator. But to do that, I need the string encoding of a string consisting of two new lines. So I can use my str to int helper function to do that. Now, unfortunately, I can't pass new lines on the command line. If I try to do something like this, it will encode actual \n/n. But I did put two new lines into a text file here, and that'll give me the number I want. Alternatively, we could calculate that number ourselves, because it's the character code for a new line, shifted left by 21 bits, because strings have 21 bits per character in Funciton. And then we add another 10 for the second new line, and then we find that that gives us the same result. So let's pass that number into our string split function. So now we've split that string into two parts, and the first part will come out of here, and that will be the set of ordering rules. Let's deal with that later. So the second part is the list of batches, and each batch is a list of comma-separated integers. So let's use the lazy string split function to split that at the new lines, and we get a list of lines of text. And then we need to map over that to process each line of text. And then each of those lines of text need to be separated by the commas. So let's use the lazy string split function again. Now at this point, we have a lazy sequence of the strings between the commas. So for example, in this case, we would have the string 7.5 followed by the string 4.7. So we might be tempted to turn those into integers by using the conversion function. But I've just been thinking that we don't actually need that. We can treat them as strings as long as the regular expression also uses the same strings. I mean, in Funciton everything is an integer, so all we're doing is we're doing the same thing just with the string encoding of these numbers instead of the numbers themselves. And that saves us this conversion. So what that means in practice is that with the sequence that comes out of here, we can literally apply the regular expression right there. And we're going to use the regex matcher that searches the entire string for matches of a regex, and then we're just going to check if that's 0, meaning the regular expression didn't match. So I want to put that function here on the right, and I'm running out of space, so I'm going to zoom out a bit. Okay, let's match the regular expression. And now what comes out of here is a lazy sequence of the matches of that regular expression. And we need to check if that's 0, so let's put an if then else here. So this is the output of the if then else. This is the if condition, in other words the value we're checking. And then this is the true branch, so this is what should happen if the regular expression did match. Well, if it did match, then we want to ignore this particular batch, which means that it doesn't contribute to a sum, so we should probably return 0. Meanwhile, in the false branch, which is here, we need to find the middle page number. In other words, the number in the middle of the sequence as demonstrated here. So let me just call that mid so that I don't lose track of what I want here. This here wants to be the regex. And this is the second output of the lambda expression for the mapping function, and the mapping function doesn't care about it, so I'm gonna put 0 there. And for that, we need a copy of that list, which we created here by splitting at the comma. So let me pass a copy of that through a wire crossing function. And now even up here, let me actually move this down a little bit, we're gonna need more space here. We're still going to need two copies of this, one to determine how many elements there are, and one to retrieve the element that we want. Now let's think about what the index is that we actually want. If our sequence has only one element, well then we want that one element that will be the middle element, and that will be at index 0. If the sequence has 3 elements, then the middle one will be at index 1, and then the next larger will be 5, where the middle element will be at index 2, because there are 2 elements before it and 2 after it, making 5. So you can probably extrapolate the formula here, right? For any sequence of length n, which we assume to be odd, we are going to subtract 1 and then divide by 2. So in the case of 5, for example, subtracting 1 gives us 4, and then dividing by 2 gives us 2. And you'll probably remember that dividing by 2 is easiest or most performant to do in Funciton by doing a shift right. We're shifting it by 1 bit, and that will chop off the last bit. But now what about that -1? Well, if the number is odd, then its least significant bit is always 1, and we're shifting that bit out. So we don't even need to subtract it. So it's literally just n shift right 1, and that's the formula that we need. So I'm going to apply that shift right directly to the result of the count function. Except that I'm going to express the shift right as a shift left -1, because the built-in operator in Funciton is a shift left. And now we want the element in that sequence at that index. And conveniently we already have an element function that can retrieve an element by its index, so I'm just going to use that. So let's apply the element function right here. And now the first argument to the element function is the sequence we're indexing into, which I have down here, but it's more convenient if I flip this around. And then we can compactify that a little bit. And then finally, that element is still a string representation of the integer. But we do eventually want to add up all the integers. So at this point, we do need to convert it from a string to an integer. So now, the thing that comes out of the map function is the sequence of those integers. It's the middle integers in the sequences that don't match our regular expression, in other words, that match the criterion that the regular expression shouldn't match. You know what I mean. So we just need to sum that up and then convert that back to a string for output. And now all that is left to do is to convert this string, which is this entire blob of text here, the first half of the input, into the regular expression that we want to pass into here. So the first thing that I think we should do is to split this at the new lines as well, so that we have a sequence of lines of text. So we're going to apply the lazy string split function again. And in the same way that we mapped over each line in the second part of the input, and then we split everything by commas, I'm going to use a map function again in order to split every line of text at the pipe characters. But in that first part of the input, we always have exactly 2 numbers in each line rather than any number of numbers. So I'm going to use the single split function again to get 2 strings instead of a lazy sequence. So now the string that comes out of here is going to be the string on the left side of the pipe character, and the string that comes out of here is the one on the right. Now, both of those are strings, and we want to maintain them as strings, because remember, our regular expressions look for the string representation of each of these numbers. But I do need to pack them into a single value in order to return them from this lambda expression, so that I get a lazy sequence of these tuples or pairs. So I'm going to use a lambda expression that just returns those 2 values. Now, if you've been paying really close attention, you will have noticed that the string that comes out on the right side of the pipe is now the first output of this lambda expression, and the other one, because it's counterclockwise from it, is the second. So that means the lambda expression comes out of here, which means that this is the input to the lambda expression, which we don't care about, so we're gonna silence that. And in the case of this lambda expression, we don't care about the second output, so we're going to set that to 0. So far so good. What comes out of here now is a list of tuples that represents this part of the input. Now the next thing we need to do is to group this by the second part of the input, which we now know is the first output of our lambda. And wouldn't you know it, I've already written a group by function, which is exactly what we need for this purpose. So let's apply the group function here and give it a lambda expression as its second argument. We need to group by the first output of a lambda, so let's call the lambda. And if this is the lambda, then this is the input to the lambda, and the lambda doesn't care about its input. So I'm going to put 0 in there, and I'll rearrange this a little so that I can reuse that 0 box that's already there. Now we only care about the first output, so let me silence the second one and then pipe the first one to the output of that lambda that we're returning. And now we are left with a sequence of groups. Now the wiki page says that the result of that is a sequence of sequences. But if we look at the documentation in the Funciton library, it tells us exactly what the inner sequences are. Each inner sequence starts with the result of the selector. So in our case, that would be the first output of the lambda, which is the second number after the pipe character, and then lists all elements in that group, which means those are still the lambda expressions, and we still need to extract the second output from them. Now what we want at the end is a regular expression that consists of lots and lots of alternations, and each element in those alternations corresponds exactly to one of those groups from the group function. So I think the best way to combine all of them into a single regular expression is to use the aggregate function, also known as fold. We can tell the fold function to start with a regular expression that never matches, and then just keep adding alternations onto it so we end up with a long chain of alternations. Now the order of the arguments to the aggregate function is the sequence first, which is this one here, and then the second is the initial value, and for that we want a regular expression that never matches. Now a regular expression, as you know, is a lambda expression, so let's put a lambda expression box here. And we want that to always return an empty sequence, aka 0, regardless of its input. So we need to ignore the input and return 0 on both of its outputs. Now what comes out of this aggregate function is the regular expression that we want, so we can join that up now. Okay, now I'm thinking a little bit ahead. And I'm realizing that what we're trying to do here is we're trying to create an alteration of multiple regular expressions, and each of those regular expressions is for one of the groups. For example, all of the 13s together is going to be one regular expression, and then all of the 53s together is going to be one regular expression, etc. But then within each group, we have a similar thing. We want each of these 13 things to then match either 97 or 61 or 29, etc. So we're going to be creating another set of alternations there. So instead of duplicating the code that I just wrote, I think it would actually be more helpful if we had a helper function or a library function that would turn any sequence of regular expressions into an arbitrary alternation of those regular expressions. So let's do that. And I think I want the result of my new function to be a little bit cleaner, because the code that we were about to write would always include a regular expression that never matches at the start of the alternation, which is kind of redundant. So in this function, I want to return a regular expression that never matches only if the input sequence is empty. If the sequence is not empty, then we are going to need to do an aggregation. Now again, the order of operations is we want to put the sequence that we want to iterate over here, then we need an initial value for the aggregation, and then we need the processing function, which I'm just going to call fn for now. But let's think about what we want that initial value to be. Remember, I don't want it to be that never matching regular expression anymore. So we need it to be the first regular expression from our sequence, which we now know to not be empty. So I need to call that input sequence to obtain its head and tail. But if the first regular expression from the sequence is already in the initial value, then the sequence of regular expressions that we're processing probably shouldn't also contain it. So we actually want this sequence to be the tail of our input sequence. And if this is where the head comes out, then counterclockwise from that is where the tail comes out. So this orientation is really, really convenient. Now let's think about this processing function. We need that to be a lambda expression that can take two parameters, in other words, two lambda expressions nested inside of one another. And the aggregate function is going to ignore the second output, so let's just put 0 in there. Finally, what do we want to do with the two inputs? Well, we want to use the alternation function. And finally, let's put a declaration box on the top. And now let's quickly write a comment to document what this function does, and then we can put it in the library. So now coming back to our main program, we can now get rid of this part of the program because that's going to be part of the n-ary alternation function we just wrote. And what we need to do instead is to modify each of these groups into a single regular expression. So this time we're going to use a map function. And the final result of that map function is going to be a sequence of regular expressions, which we can just pass through the function that we just wrote, and that will give us the regular expression that we need. I seem to have deleted the 0 here, so let me quickly put that back in. And now we need to write the lambda expression for the map function. So what comes out of here is one of those groups. And a group, to remind you, is a lazy sequence where the first element is the thing that we grouped by, which is the second number in each of our input lines. So let's call that lambda expression to extract that first element. The rest of the sequence, which is the tail, still consists of those pairs that we created over here. So let's use a map function here to extract those. So what comes out of here now is one of those pairs, so we need to call that to obtain its second output. And now that second output is a single string. It is one of the elements to the left of the pipe characters from the initial input. And we want to turn that into a regular expression that matches just that element. So I want to use the function that creates a regular expression that matches one occurrence. But you'll remember that in the past I have often combined it with this function here to turn a string into a lazy sequence of its characters. But importantly, we don't want to turn our strings into a sequence of characters. We want to treat the string as a single element. So what we need is a function that will take one element and create a lazy sequence containing just that one element. Let me just scroll up a little bit and whoa, it's right here. Don't be distracted by the weird name. Just like the bind function, when I wrote these functions I was somehow into monads. And this is the monadic return function, which literally just takes a single value and returns a lazy sequence containing just that one value, which is what we need right now. So let's turn the string into a lazy sequence containing just the string, and then that into a regular expression. And now what comes out of this map function is one of the inner regular expressions, like one of these. We now need to combine it with the head in order to create this kind of regular expression. So let's think about the structure of this regular expression, right? We have the head element, and then we need the then operator because something is followed by it. And then we're going to need an equivalent to the dot, in other words, a regular expression that can match any element. Then we need to apply the repeater to that. And then we need another then operator, because that needs to be followed by that whole alternation that we just created. Let's start by creating a regular expression that matches any element. I could use this function that I've created before, which takes a criterion, so I could just have a lambda expression that always returns true. But I think it would be more useful to have a separate function for the special case, to just match any single element. So I'm going to copy this function and modify it in order to create that. This time I'm going to start by changing the comment. Now let's remind ourselves how this function works. Of course it returns a lambda expression because regular expressions are lambda expressions. And then it needs to check whether the input is empty, and if it is, then there is no match. But then the next thing the function does is to check whether the next element matches the criterion that was passed in as a lambda expression, which we don't want anymore. So let's start by removing that part of the function. And let's also change the name of the function in the declaration box. Now, if the sequence is not empty, in other words, we're here, we actually want to return this, don't we? This is a lazy sequence, represented by a lambda expression, that returns a single match object, also represented by a lambda expression. And the match object creates two outputs, the first one of which is the rest of the input sequence, and the other one is an associated result value. Now I'm going to maintain the behavior that the result value is the element that was matched, which means that we want to split the input sequence into head and tail, and we want this to be the head and this to be the tail. And we're doing that splitting right here. We're passing the input sequence right here. We're passing in 0 as the input to that because it doesn't care about its input, which means that this is where the head will come out, so it's already going into the right place. We just don't need this anymore because we're no longer checking the head against any criterion. And then this is where the tail comes out, which is also what we want. It goes right in here. So this means that we can actually just connect everything up directly. But that highlights a problem that we have, which is that our function doesn't actually take any input. So this will be the first time that I'm creating a function with basically 0 inputs, but Funciton doesn't allow that. So I need to provide an input, but I need the function to ignore that input, and I'll just always put 0 in. So let's compactify the rest of the function, and then let's think about how we do that. Okay, so some value comes out of here, and we definitely want that value to be ignored, meaning not evaluated. Now you already know about the flag construct, which looks like this, which we often use to ignore an input, but we can't use that here because there's no line coming out of it, but we need to connect it with the rest of this function. So we need to come up with something else. Now, if you remember back to the second video that I ever made about Funciton, the one in which I describe how to do addition, you may remember that one of the built-in operators in Funciton, specifically the NAND operator, which looks like a T-junction, has short-circuit semantics, which means that it will ignore its second operand if the first operand was 0. Because if the first operand is 0, you already know that the result is going to be -1. So let's put a 0 here. So now we will always have -1 come out of here. Now what can we do with a -1? Let's think about what happens if we do a NAND again. So let's say we NAND that with a value x. What comes out of here? Well, the answer is it's the bitwise negation of x, which we can cancel out by just performing a bitwise negation right after. So now you can see that we can put any value x here, and that exact same value will come out of here, and we will have connected this with that. So I'm going to put the actual result of this function, which is this lambda expression, in for the x. And now, if I haven't made a mistake, we have a function that takes an input but completely ignores that input and returns you a regular expression that will just match any element. So let's put that in the library. And just as I'm putting this in the library, I noticed that I have this extra line sticking out of here, just in case you saw that, just letting you know that I noticed it and I fixed it. Okay, now let's come back to the main program. Remember that the head that comes out of here is actually the element that we want to match at the start of this regular expression. So we want to apply our first then operator to that. Next, we need the dot star. So we need to apply the repeat operator to the single element function we just wrote. And then we need to apply the then operator again before we get to the big alternation. So let's add a second copy of the then operator. Now the final result of this, where does that go? Well, it needs to go in here. It needs to be the output of our lambda expression, because this is the final regular expression that we need. So let's put in a y-crossing function to make that happen. And what do we need to put here, the second argument to the then? Well, that wants to be that big alternation. But all we have right now is the result of this map, which is a sequence of the regular expressions that we created here, each matching a single element. So we still need to run that through the n-ary alternation operator that we wrote earlier. And with that, I think I've successfully joined everything up. Let's zoom out a little bit to see more of the program. So this is what the whole thing looks like. And I just noticed this unnecessary kink here, so my aesthetic senses are tingling, so I'm quickly gonna fix that. There, I think that looks a lot nicer. Now, I haven't done any intermediate testing, so if this monstrosity of a program works first try, that would be impressive, right? So, big moment of truth. Let's run that on the example input given by the puzzle, and I get an error message about an incorrect number of connectors to the call to this function here. And it's this function here to retrieve an element by an index. So let's take a look at that function in the library to see what I'm doing wrong. Well, here's that function, and we can see that it does indeed require 3 inputs. Now, the first thing that the function does is to check if the first input is 0, so that'll be the input sequence. It's checking whether it's empty, and if it's not empty, it takes it apart into head and tail here. The second argument is passed into this to check whether it's 0, because if it is 0, then we're looking at the first element in the sequence, so we're returning the head. And if it's not 0, then we do a recursive call with a decremented value. So that third value that we need to pass in is something that is passed here. So this is a value that gets returned if the sequence is empty. So clearly that is some kind of default value that will be returned if the sequence is empty or if the index is out of bounds. Now, how are we going to fix this? This is where we want the output to come out, which means that in counterclockwise order we need this to be the sequence, which it already is, and then we need this to be the index, which is currently here. And then here we need that default value, and we don't care what that default value is. So I'm actually just going to reuse the -1 box as the default value. I think that that is correct. Famous last words. Let's see what happens this time. Oh boy, I am attempting to invoke a lambda with a large value. Okay, I've looked at that value in binary and took it apart, and it turns out it's the integer representation of the string 75, which occurs in all of these places in the input. But in particular, it's the very first number in the second part. So I think that I've accidentally used the string here as a lambda expression. Did you spot my mistake? The problem is that we put the parameters the wrong way around here. This function expects the regular expression first, and then the string to match against. So we need to turn that around. Now this looks a lot more spaghetti than before, but hopefully this is correct. So let's run this once more, and we get a 0. which is obviously not the correct answer. Alright, after intense reconsideration of my life choices, I think I have found a bug in the program, but it doesn't really explain why we're getting 0. But I'll explain what it is anyway. So, you remember that I said that the group function will return a sequence of sequences, and each of the inner sequences starts with the element that it was grouped by, which in our case is the second element in each of these tuples. So we mapped over that sequence of sequences, which means that this lambda expression will receive each of these groups, which is one of those sequences. And then we used this invocation of the lambda expression to obtain that first element. And then I made the mistake of pumping that directly into a function that requires a regular expression. So I'm going to fix this by turning that element into a regular expression that matches just that element, and then I'm going to run the program again. But I kind of expect this to still return 0, and let me quickly explain why. You see, regular expressions are lambda expressions, so I expected this then operator to use the first output as a lambda expression, and if that number is one of the strings from our input, in other words, the integer encoding of something like 53, then trying to call that as a lambda expression should have given us an error message similar to the one you've seen before. But that said, let's just run this again and see what happens, and of course I was right. So, back to the drawing board, I guess. So, after a lot more thought about this and taking the program apart from top to bottom, I finally figured out what the problem was. And it turns out that I introduced the problem by trying to fix it. You remember the first thing I fixed was the argument order on this function, the regular expression match function. And then the second thing I fixed was the missing regular expression constructor down here. Well, it turns out that I was wrong about this. I should not have done this. I had the argument order correct all along. In hindsight, I'm not exactly sure what motivated me to change this, given that it was correct. I'm gonna have to watch this video back to find out. So let's quickly put it back. And now let's give it another go. Drum roll. 143. And looking at the puzzle page, that is indeed the right answer. So wow, after the 5th attempt or so, I finally got it. So now I need to run it on the full input, and as always I'm going to measure the time that it takes, and then I'll come back when it's done. Now that is a new one. OutOfMemoryException. Wow, I'm going to have to sit down and really think about how to deal with that. Well, believe it or not, I managed to run it. And here's what happened. It turned out I compiled the Funciton interpreter as a 32-bit process. I wrote it a very long time ago when .NET was still preferring 32-bit. But anyway, I've changed that to a 64-bit process now. And the memory consumption while running this program that we wrote in this video ran up to 7 or 8 gigabytes. So actually no surprise that it ran out of memory for a 32-bit process where the limit is 4 gigabytes. But long story short, it took only 3 minutes 37 seconds, which is pretty fast compared to other solutions that we wrote for other Advent of Code problems. So let's finish this off by copying this answer and pasting it on the bottom of the puzzle page. And it turns out that's the right answer, so we have finally finished the first challenge on day 5, and we are 1 gold star closer to finding the chief historian. Now, if I had to take a guess as to what the sequel is going to be, I have a suspicion that we're going to have to actually reorder some of the rows in such a way that the ordering criteria are met. So let's find out if I'm right in the next video.